Welcome for this new value set of Rustify. What if React and Next.js had a baby and this baby was written in Rust? Maybe you didn't ask this question yet. I'm asking you, and the answer of this is Leptos. Leptos is a Rust Fullstack framework. It's very similar as what we have with Next.js, but it's just for Rust. And this is the topic of today. So today I will explain you all of this. I will give you a lot of value for free. And I will explain you mostly with diagrams and also with infographics like this, so you will understand the difference between React, Leptos, Signal, Solid.js, Next.js, and everything. Okay, so I highly suggest you to watch the video until the end, and it will make more sense for you. Okay, so first Leptos, it was built by Greg Johnson. So this guy. And the idea was to take the lessons of Signal, of Solid.js, but to apply this for Rust, okay? So it's not using the similar pattern as React, it's using more the pattern of Solid.js, okay? We will see that just after. You can do a lot of cool stuff with this. So this is an example I've built, so rustify.com. So you can, it's very similar as React or Next.js. You can build also components and stuff like this. So here, of course, it's just the front end, but of course you can do also full stack application with this. And there will be more, there will be a lot of examples on this channel. So you can watch this after watching this video, please. But there will be a lot of video on this channel on how to build full stack application using only Rust. Okay, so you can check this also. Okay, so first, maybe you are asking yourself what's the difference between React and Leptos. So you already know that React is a library. Okay, so we have React as a library, Next.js as a framework, and Leptos actually is combining both Next.js and React. Okay, so Leptos is kind of both a framework and a library. Library in the sense that it handles also reactivity, okay, and it's also in the framework in the sense that it also handles routing and all that stuff, okay. So we will see that just after. So first, when you think about React application or whatever, of course you think about reactivity. So what is different between React and Leptos for this? So Leptos, as you can see here, use fine-grained reactivity. So what it means is that it means that instead of React using a virtual DOM, Leptos does not use a virtual DOM, it uses the DOM directly, okay? And the way it works is like this. So you have, for instance, count.set, you set 5, okay? The signal notifies, and then the DOM node updates immediately. Does not use a virtual DOM and patch and everything. This is complex, and it does not use this, okay? And this makes faster also for DOM node updates using Leptos than React, because it doesn't need to do the diff with the virtual DOM, okay? If you look at React, virtual DOM, okay? So here you would have set count, for instance. So this re-renders the tree, and then we need to do a diff of the virtual DOM, and then to patch the DOM. And of course, it requires much more computation to do the update, right? And this is one of the benefits of Leptos is that it's better, it has a better design for this, okay? Just because it uses the DOM directly. So to understand that better, you can have a think like this, it will help you. So when you think about Leptos, you have, for instance, a div with h1, span, p, and whatsoever. When you want to update the count, since it only updates the specific node that it needs to update, it means that it will update only this. And the issue with React is that it updates all the parents, okay? The whole component renders, okay? And this is what Leptos tries to solve, among other things, of course. But this is one of the main benefits of Leptos for the reactive world, okay? Other key differences, so Leptos, no virtual DOM overhead, okay? So hopefully you understand this. Granular updates, because it's fine-grained reactive system, right? Less memory usage, because you don't need to parse the whole virtual DOM and everything. It's also compatible with Rhythm, right? Because we are using Rust for this. And no re-render cascade. Also, of course, React has still advantages also, because the ecosystem is better. still at the moment. More learning resources, better tested also at scale. It's not yet the case for Leptos, to be honest. Also rich tooling with dev tools, easier hiring also at the moment, but probably in a few years, we will see. Okay, so hopefully the difference between React and Leptos is clear for you. So if you think now about what is the flow for the reactive world inside Leptos. So you can think this way. So they are the same. So I will show you with this, it will be easier. So basically you first create a signal, right? So also the difference between React and Leptos is that in React, you use states. In Leptos, you use signals, exactly as Signal.js, and we will see that just after. But first you create a signal, right? You can use RW signal exists, so it's for read-write signal. So the signal is created. And then you have different choice. So you can either have create effect or create memo. So this is the old version. The new version is effect new or memo new, but it's kind of the same. It's similar as React. So either you create an effect, so it means that the effect runs, and then we have side effects, or you can use a create memo. Okay, so then the memo will be computed, and then it will catch the value. Okay, and otherwise you have the render of component like this. And then you have the read signal, okay? Because you remind that it's a read-write signal, okay? So you can either read or write. So this one to get is to read the signal, okay? So once you have this, the dependency is tracked, okay? Then it renders the UI. Then there is the user action, right? It updates the signal, okay? So here we are in the writes. So either we set or update. The signal changes, then it notify subscribers, and then it re-renders the components. And we are go back to reading the signal. And that's, once again, for instance, every time you click a button to increase the counter, it will trigger all of this, okay? So you can see kind of the difference between React and Leptos with this, right? Okay, so I was telling you also about Solid.js and Leptos. So what is the difference between the two? So maybe we will start first with the syntax comparison. So in Leptos, it looks something like this. We have already seen that we have RW signal. Okay, so here it's RW signal new with the values that you want. So for instance, 0. And then you have count.get, for instance, or count.set. Okay, so this is for read, this is for write. Because you remind read, write signal. Okay, in Solid.js, you have something like this. So you have, it's more similar as React. So you have the counts like this with the array count, set count, we create the signal. And then the different stuff here is that you use a function for this, so to read, and also to write it's like this. Okay, so nothing complex. They have similarities. So the first similarity is that they are both fine-grained, because I was telling you at the very beginning that Leptos use Signal, get inspired by Signal to create the framework. Okay. So first thing is that it's fine-grained. This means that there is no virtual DOM, okay? Because we are not in React, it's using the DOM directly, okay? We still have also signals and effects, and also compile time, okay? So optimization happens at build time, not runtime, okay? Okay, but there is still some key differences. The first one is that Leptos' strength is that it's memory safe. There is a main focus on memory safety, okay? And we have also ownership rules of Rust that applies, okay? So it helps also for this. SSR plus addressation built in, okay? So this is also a very good stuff about Leptos, is that it integrates very well with SSR. So SSR, you know that it stands for server-side rendering, okay? So you can have both server and clients, okay? It will compile for both targets. You have also server functions, so I will create more videos about this. We will code together to show you exactly how it's done using concrete projects, so you will understand this. And also, of course, the benefits of Rust is that you have also WASM. Solid.js has also strength, so similar as React, so the ecosystem is larger, easier learning curve, also more NPM packages, because there is a larger ecosystem, and faster compile times, okay, also. because one of the drawbacks of Rust is the compile time. So you will see that when you will use Rust, it's kind of a pain. But yeah, this is the only drawback actually of Rust. Okay, so we have seen, we have seen Leptos React, we have seen Leptos Solid.js for the reactive world. Now I want to explain you a little more also how resources work, because you remember that I was showing you about SSR, server function, and everything. Okay, so it means that you are in async, and you need to handle the async. And the way it works in Leptos is with resources. Okay, so async data fetching with create resource. Now it's more resource new. Fetch once, react to changes, handle all states. So the way it works is something like this. So for instance, let user, so it's resource new now. And then you need to use move. So move, it means that you are in the reactive world of Leptos. So I will explain you that also more in details in coming videos. But basically you have this, you have still, you remain the get, okay? And I mean, the most important to understand for this, for the create resource, is that you have both a source and a feature, okay? Just this. And then so you can have different states, of course, using resource. It can be either loading, success, or error, okay? And the way you can get this is using loading like this, or user.get. We have already seen that with, because it's read also signal. And we have also error boundary if there is an error, okay? Once you have defined your resource, you can use suspense. Suspense or transition. Here I'm showing you suspense, and it looks something like this because you want to, while it's fetching, for instance, data from the database, you want to display a loading state, right? And the way it's done is something like this. So you have the suspense, and then you can use a fallback using the view macro, and you can display the view that you want to show the loading state, right? And then you remind that you need to use the move keyword because you are in the reactive world of Leptos. And then you get the user when it's done, when it's good, and when you have it, you can display a view with the user.name or whatever. Okay. So this is the syntax that we use, and as you can see, it's not very complex to understand, and it works perfectly fine. Also, when you use resources, sometimes it can happen also that you have iteration issue. So iteration issue is a mismatch between what is rendered on the server and what is rendered on the client. Okay. So here it's also the same schema, the same diagram I will show you here. But basically the workflow is that, for instance, you go in my page, for instance, or user ID, whatever, and then the server receives it. Leptos SSR runs the components, because you remind that when you are in SSR modes, we first run on server and then we iterate on client, okay? And then, so the signal executes because the iteration happens when there is an issue with the signal. And then we have the HTML, we have also the data which is serialized, okay? The response is sent, and then you have this, so we parse the HTML, and we have also the WASM that downloads. The WASM is ready, okay, and then the iteration starts. So basically you are first inside the page, the HTML loads, and then the iteration starts. And sometimes it's possible that there is an issue with the HTML and what is rendered on the client, okay? And this is because there is a walk DOM tree, okay? Then we attach the listeners, and then we reconnect signals, and this is where sometimes it can be an issue, okay? So just for you to have the global pattern for this. This is a little more complex. You don't need to understand this perfectly. Just remind that we are in SSR, so it means that on the server, it will first render, and then the client will iterate this, basically. Also, I've created another one for the routing flow. Maybe you are also asking how Leptos handles the routing, because you remind that I was telling you that Leptos is both a framework and a library as React. Okay, so both React for the reactive world, let's say, and both also Next.js for the framework with the routing and everything. So how does it work for the routing? It works like this. So you have, for instance, a URL like this, users, 5 posts, for instance, and then the router parses the URL. And what we have we have different match different routes. So we can have either the home, either about, users, and everything. And you remember that what we want is to go on users. So here we are in this particular route, okay? And then inside this particular route, we can also have nested routes under users. So we can have the user list for users, just users, but we can also go in users/the ID. And here we will have the user detail, right? And you can also have users/ID/post. So exactly what we have here, user/5 post. Here we would go inside users ID post like this, and we will have the user post. And for this, you can see that what we have here is what we call a param. Okay, so the 5 here is a param. And the way it works in Leptos, and don't worry, we'll see that in other videos, sorry, is that you have the extract param like this, so you get the ID basically, and then you have the render layout, because you can have also layout in Leptos with an outlet. Then you render the child, and then in the final UI, so you have both the layout and the nested view, okay? And then the user click the link, so it can be also to go inside in other users. And if it does this, so if it goes from 5 to 3, what happens is that, and this is very important, is that there is no page refresh. So all of this, actually, all of what I've explained you about client-side rendering, SSR, and everything, the main benefit of using this way of doing is that there is no page refresh. It's only client-side navigation. And it means that in terms of UX, it's much better. Okay. And then we are in here. So it goes, you remind, from 5 to 3. And then we go here, boom, boom, boom. The router parses the URL again. It does the match routes. We go inside here and we go inside here and again. And here, the extract params will be 3 instead of 5. So fully on ensemble, okay? Okay, so if you're still here, it means that you are interested in learning Rust because watching me for 17 minutes with this complex stuff, it means that you are really interested. So it means that you probably want to learn Rust. So you can send me them on LinkedIn. We have a bootcamp to learn Rust in 9 weeks and also to find a job very rapidly. So if you're interested, just send me a DM, because if you still watch this video, it means that you know that we are the best to help you. Even if it's in 2 months or 3 months or 4 months, doesn't really matter. You know that we are the best for you to help you. So feel free to send me a DM and we can work together. Also, of course, we are very selective about the people who we help. Okay, so if you are still a student, or if you don't have the money to take the bootcamp, or it's not really a bootcamp, it's more coaching actually. It means that it's not for you. Okay, so yeah, that's it for today. I hope you enjoyed and see you next video.